Inequalities. Now we're getting to the good stuff. So we've the last couple days been looking at solving inequalities, right? We've been using inverse operations. One of the days we did when you have addition or subtraction inequalities, which looks very similar to when you have solving equations with addition or subtraction. And then we also looked at what happens when you are solving inequalities that have multiplication or division. And I had said that this is going to be a 2-day lesson. Well, here is the second day of that lesson. First off, just backtrack real quick. When you solve an inequality, use inverse operations, and we can look at an example to really highlight how that works for those of you who might still need to see it a bit. For this first example, it's going to be one similar to what we looked at yesterday. We're going to have x divided by 5 is less than or equal to -3. So to solve this, what you really need to pay attention to when you are solving inequalities is what inverse operation are you using. In this one, my inverse operation is to multiply by +5. And when you multiply or divide by a positive, everything is as it would be when you solve equations. You just do the same thing to the left and to the right sides of the inequality, and you'll have a final solution. So x is less than or equal to any value that is less than or equal to any value that is -15. So if I was going to graph that on a number line, I'd use -15. And here we go. This would require a closed circle because -15 is part of the solution set and it's all the numbers less than and including -15. So my arrow goes to the left. Yes, we've done this. This should be old news. This is not a new example. Where things get to be a bit new, this is where you really want to pay attention and hone in on what I'm talking about. There is a special case that applies only to multiplication and division as an inverse operation when solving inequalities. If you ever have an inverse operation that is multiplication or division that includes a negative number, multiplication or division by a negative number, I really want to highlight that phrase, then to make the inequality true, you have to flip the direction of the inequality sign. First off, you might have two questions. One, what the heck? And two, why? Why would you have to flip the sign? Well, let's look at a very, 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 very basic example to try to prove this to you. If I had the inequality -4 is less than 6, is this inequality true? Most certainly. -4 is less than -6. Now, when you are solving inequalities, you use inverse operations, and what that entails is doing something to both sides of the inequality. So, for example, you might have an instance where you have to multiply both sides of the inequality by -2. So let's do that to this inequality. Let's multiply both sides by -2. So if I multiply this side by -2 and this side by -2, my inequality would then say -2 times -4 is +8, and 6 times -2 is -12. I did the same thing to both sides, so that should leave everything hunky-dory. But look, this is now untrue. 8 is not less than -12. That is totally untrue. How can I make this inequality true? Because it's not true right now. The only thing that I can do is I can flip the direction of the inequality sign. That will then make this a true inequality. 8 is greater than -12. It seems a little bit weird, but if you ever have an inequality that you are solving and the inverse operation asks you to multiply or divide by a negative number, so that the number that's being multiplied or divided is negative, then to keep the inequality as something that is true, you must reverse or flip the direction of the inequality sign. And I think what would be helpful is to look at this in practice. So let's do a real problem. Let's say I had an inequality that says negative 3z is greater than negative 4.5. Okay, so my inverse operation here is asking us to divide by negative 3. And I'm going to divide by negative 3 on both sides. Since I am dividing by a negative number, since the inverse operation is an operation that involves a negative, I know that to make my final inequality true, I have to flip the sign. So what's left over here is z on the left-hand side, and on the right-hand side, I have positive 1.5. So what that tells me is if I want this original inequality to be true, all of the values for z have to be less than positive 1.5. And let's just graph that real quick. All right, now to prove this, pick something on either side of the inequality and plug it back in. If I picked positive 2, for example, 2 times negative 3 is negative 6. Negative 6 is not greater than negative 4.5. So none of this stuff is going to be true. All of my true stuff should be to the left of positive 1.5. So let's choose positive 1 to test it out. Negative 3 times 1 is negative 3. And negative 3 is greater than negative 4.5. Aha! So I know that all of my truth is going to be to the left of positive 1.5. And the key to this is remembering that when your inverse operation includes multiplication or division by a negative number, you must flip the direction of the inequality sign so that your final inequality statement remains true. Let's look at another example. Let's look at negative 3 halves times n is less than or equal to positive 6. So the first thing that I'm going to do is notice that I'm working with a fraction. Personally, I prefer to just, since I have to divide by negative 3 over 2, division of fractions is the same as multiplying by the reciprocal. So I'm going to multiply by negative 2/3. It's going to still cancel out, and it's going to leave me with n on this side of the inequality. And on the right-hand side, I'm going to multiply by the same thing, negative 2/3. 6 times negative 2 is 12. And did you catch my error here? You have to flip the direction of the inequality sign if it's going to remain true. If you multiply or divide by a negative number, you have to flip the direction. This inequality statement is true. And actually, we can make it look a little bit cleaner. We could simplify that fraction. N is any number that it's greater than or equal to negative 4. And I think by now we all know what this looks like on a graph, but just in case, I'll do the graph. That's going to be a filled-in circle because it includes negative 4 as part of the solution set, and any number that's greater, which means my arrow is going to be pointing to the right. All right. This is a little bit weird, I know. However, this is how you keep inequalities true when you're solving them and it involves multiplying or dividing by a negative. So today's your day to practice that. Please, please, please pay attention to the directions in the practice problems. We're very specific about when you should or should not be reversing the inequality symbol. Think about what you're doing. Pay attention to the directions. Pay attention to the problem themselves. And I'm actually going to do one of your practice problems for you because I think that this is something that might fool you. So the very, very, very first one is 12k is less than or equal to negative 24. And the inverse operation here is to divide by 12, and that's going to leave k. And then on the other side, it's going to leave negative 2. So I'm sure that there are some of you, I would have gotten fooled by this possibly as well, that would say, oh, I divided by a negative, I need to flip the sign. No, there is a negative number in the division problem, negative 24, but you divided by a positive number here. There is no flipping of the sign that occurs. This inequality is true. This inequality is correct. You don't need to flip here. You only flip if the actual number that you're dividing, in this case, positive 12, if this was negative, then you would flip the sign. So hopefully that helps point you on the right direction. You've got about 10 or so, I think 12 actually, practice problems. Please ask us questions. Please join Google Meets if they're available. And do your best, take your time, use these notes in this video as a resource, and good luck.